Salam everyone. Today we are going to discuss problems based on trains and their speeds, because this is also one of the most important topics in quantitative aptitude tests. I will explain some very important tips in order to solve these kinds of problems. So let's start. So point 1, in the case of a pole, a tree, or a man the distance traveled by a train is taken as the length of the train itself is equal to length of the train itself. Length of the train. So if in the language problem we see that one train is being discussed and with the reference of a pole or a man or a tree, the distance traveled by the train to cross over that man or pole or a tree is equal to the length of the train itself. Second important point is in the case of a train and a bridge, or a platform, the distance traveled by the train to cross over the bridge or the platform cross over the bridge or the platform is equal to length of the train plus length of the bridge. Length of the bridge, and in the case of platform, length of platform. Length of train plus length of the platform if platform is discussed with the train, or the speed of the train or the distance of the language problem. One train and the platform are given in the language, then we may say that length of the train plus length of the platform, or if bridge is there, then we may write length of the train plus length of the bridge. Point 3, in the case of two In the case of 2 trains. In the case of two trains, the distance traveled by each of the trains is equal to sum of lengths of both trains. So as you see, the general principles behind these points are, if the width of that object in the reference of which we are discussing the motion of the train is very small as compared to the length of the train, it is neglected, and distance traveled by the train is considered equal to that of the length of the train itself. As in the case 1, there is a pole or a man or a tree with the reference of a train, or we may say the motion of a train with the reference of a pole or a tree or a man. As you see, the width of a pole or a tree or a man is very small as compared to the length of the train. So in that case, the width of these objects are not considered, and the distance traveled by the train is taken as the length of the train itself only. In second case, if the second object in the reference of which the motion of the train is considered or discussed is not very small as compared to train, or that is large distance or large length as compared to the length of the train, then the distance traveled by the train is taken as the sum of both the lengths, length of the train plus length of that object which is considerably long. As in the second case, we are taking a train and a bridge. So as you see, the length of the bridge is not negligible in comparison to the length of the train. So in that case, we have to add them both to find the length, to find the distance traveled by the train. Or in the case of platform, the same thing. So length of the distance traveled by the train to cross over a bridge or a platform is equal to length of the train plus length of the bridge or length of platform, whatever is the case. In the case of two trains say T1 and T2. Suppose T1 and T2 are two trains if case first, if the trains are moving in the same direction, T1 and T2, both the trains are moving in the same direction, and the speed of train 1 is V1, that is speed of train 1, and V2 is the speed of second train T2. The relative speed of train 1 with respect to train 2 is equal to V1 minus V2. We have to subtract the speed of the train 2 from the speed of train 1. So V1 minus V2 is the relative speed of train 1 with respect to train 2. And the relative speed of train 2 is equal to V2 minus V1. If we have to find out the relative speed of second train with respect to the first train, we need to subtract the speed of the first train from the speed of the second one. And the second case, if both the trains, train 1 and train 2, are moving in opposite direction. In that case, relative speed of T1 or T2, both, in both the cases, whether we find the relative speed of T1 with respect to T2 or relative speed of T2 with respect to T1, each of these two speeds is equal to the sum of both the speeds, V1 plus V2, speed of the train 1 and speed of the train 2. This is the relative speed of T1 with respect to T1 or relative speed of T2 with respect to train T1. So we have taken the example, a train 100 meter long is running at the speed of 30 kilometers per hour. Find the time taken by it to pass a man standing near the railway track. So here we observe that the length of the train is given as the length of the train is given as 100 meters and the speed of the train is given as 30 kilometers per hour. So we need to be very careful about the units. If the length of the train is given in the meter, the velocity must also be, the speed of the train must also be in terms of meter per second. So first we have to change this kilometer per hour into meter per second. So as you know, there are 1000 meter in 1 kilometer, so we need to multiply it by 1000, and in 1 hour there are 3600 seconds, so we have to write 3600 in the denominator because this is kilometer per hour. So in the numerator we have to multiply, we have to change kilometer into meter, and in the denominator we have to change hours in seconds. So 20 we may cancel by 20, so we have simply 30 into 10 upon 36. 30, 10 is left over there and 36 over here. So now 6 5s are 30, 6 6s are 36, and now 2 may divide both of them, 2 5s are 10 and 2 3s are 6, that is 5 5s are 25 upon 3 left in denominator, that is meter per second. Now we have changed kilometer per hour into meter per second, right? So as I have explained in the beginning, in the case of a man or a pole or a tree, the distance traveled by the train in order to cross over is exactly equal to the length of the train itself. So length of the train is given as 100 meters, so that means the distance traveled by the train to cross over the man is equal to 100 meter, and the speed of the train was given as 30 kilometer per hour, and we have changed it into meter per second, that is 25 upon 3 meter per second. Now we know that speed is equal to distance upon time. So out of these three physical quantities, we have to observe that which is required in our language problem, that should be transposed to left hand side, and the rest of the terms or rest of the quantities should be transposed to right hand side. So here, as you know, we have to find the time taken by the train to cross over the man. So time should be transposed to left hand side and speed to the right hand side. So this formula may also be written as time is equal to distance upon speed. Now distance is equal to 100 meter and speed is equal to 25 upon 3. So as you know, this 3 goes in the main numerator because this is the rule that denominator of denominator is shifted to main numerator. So 3 into 100 divided by 25, as you know, 25 will divide 100 4 times, and we have only 3 into 4, that is equal to 12. 3 4s are 12 seconds. Why seconds? Because we have used the speed in terms of meter per second, in units of meter per second. So if we have time, its unit must be second. So finally we have found the time taken by the train to cross over the man, that is equal to 12 seconds. So this is how we solve language problem based on trains and their speeds. Next example is a man is standing on a railway bridge which is 180 meter long. He finds that a train crosses the bridge in 20 seconds but himself in 8 seconds. Find the length of the train and its speed. As we know, the speed is equal to distance upon time. First we assume let length of the train is equal to x meters. We have assumed the length of the train as x meters. So in the case of a bridge, as we have discussed in the beginning, the distance travelled by the train in the case of a bridge is equal to the length of the train and the length of the bridge. So in the case of a man, the distance travelled by the train is the length of the train itself. So if we take the case of the man, the speed of the train remains the same while it is crossing a man or it is crossing a bridge. So what is the speed distance travelled by the train? That is x, because in the case of a man, the distance travelled by the train to cross over is taken exactly the length of the train itself, and we have assumed the length of the train as x. So in the case of a man, distance is x. Distance, that is the length of the train itself, and time is 8 seconds. The train crosses over the man in 8 seconds. So distance is x, length of the train, and time 8. And this is the speed of the train which must be the same in the case of the bridge, because the train is same. The same train passing through the bridge is crossing over the man. So in the case of bridge, the distance travelled by the train must be taken as the sum of the train sum of the length of the train and length of the bridge itself. So the total distance traveled by the train must be x plus 180, because 180 meters is given as the length of the bridge in the problem, and length of the train we have assumed as x. So total distance traveled by the train in the case of the bridge, to cross over the bridge, is x plus 180, and divided by time. Time is given as 20 seconds. So the train crosses the bridge in 20 seconds, so time is 20. So this is the speed of train, this is also speed of train, and the speed of train is same, so that's why we have equated these two cases. Now, as you know, 4 may divide both of them. 4 2s are 8, 4 5s are 20, so simplify a little bit. X upon 2 is equal to x plus 180 upon 5. Now, for further simplification, we have to cross multiply. So 5 into x is equal to 2 will multiply x and 180 by transposition. So 2x plus 2 into 180, that is 360. Transpose 2x to this side. So we have 5x minus 2x is equal to 360. 5x minus 2x, 3x is equal to 360, and x is equal to 360 divided by 3, and 3 will divide 360 120 times. 3 1s are 3, 3 2s are 6, and 3 0s are 0. So 120. So finally we have found the x is equal to 120, and what is x? We have assumed as the length of the train. So that means the length of the train is equal to 120 meter. Thus, length of the train is 120 meters. Next thing required, find the length of the train, we have found, and its speed. So what we have to do now, we have to find the speed of the train. So to find the speed of the train, we may substitute x is equal to 120 either on in the left hand side of this expression or on the right hand side, because both are speeds as we have discussed earlier. So x upon 8, and x is 120, so write down 120 upon 8. Since distance is in meter and time is in second, the unit of the speed becomes meter per second. So just simplify them. Eight ones are 8, 4 are left 40, 8 5s are 40. So 15 meter per second. 15 meter per second is the speed of the train, or if we need to find the speed of the train in kilometer per hour, so simply we have to multiply it by 3600 upon 1000. Always remember to change kilometer per hour, meter per second. We need to multiply the figure by 1000 upon 3600, and reverse. If we need to find out, if we need to convert meter per second into kilometer per hour, we have to multiply the figure by 3600 by 1000. So 2 zeros are cancelled. 5 3s are 15, 5 2s are 10. So we have 3 into 36 upon 2. 2 will divide 36 18 times, and 18 threes are 54. 54 kilometers per hour.